Hey, just a quick summary of what you've learned so far in organic chemistry, and this kind of hopefully brings a little bit of it all together so you can kind of see, hey, here's where I should be, and here's what I know at this point. Whoops, what we have done so far is we've covered kind of naming and drawing and identifying all of these different things. So I have organic compounds, which is of course what we're in, is talking about all different types of organic compounds. And we've talked about both hydrocarbons and hydrocarbon derivatives. So hydrocarbons meaning I just have carbon and hydrogen, and then derivatives meaning I'm adding in other stuff, like for example, oxygen or halogens or whatever. So under hydrocarbons, I have kind of two main types. I have aliphatics and aromatics. So aromatics for you guys just means it has benzene in it, and you learn about benzene and its structure. Aliphatics means not benzene. Under aliphatics, we have alkanes, alkenes, and alkynes, which is just kind of defined on the fact of what kind of bonds do we have between the carbons, right? If I have a double bond between the carbons and I have alkenes, if there's any double bonds, it's an alkene. And if I have a triple bond at all, any triple bond, it's an alkyne. And then I also have the cyclo variant. So if I have a closed circle anywhere in that structure, then it's a cyclo as well. So a cycloalkane, cycloalkene, or a cycloalkyne. One tool that I want to bring up that is really useful for the formulas for this kind of stuff is just realizing that whenever I have a closed shape, I lose two hydrogens, right? When I have a double bond, I lose two hydrogens, and when I have a triple bond, I lose two hydrogens. So this has a closed shape and a double bond, so I've lost two for the closed and two for the double bond. So I've lost four hydrogens from its normal formula. Well, here I've lost four for the triple bond and one for the closed shape, so I've lost six hydrogens for the cycloalkyne. So why does this matter? Well, if I was trying to figure out the formula for this structure from a line diagram, I could count 1, 2, 3, 4, 5 carbons, right? So C5. I know that an alkane is 2n plus 2. So 5 times 2 is 10 plus 2 is 12. So I'm starting at 12. And then given that I've lost 6 hydrogens, I know that this is C5H6. So triple bond, take away 4, and then closed shape, take away another 2 for a total of 6. I take that away from the 12 and I end up with that. So if I had kind of another structure, let's say I had something with a, this and then this. I know that's ugly, but let's just go with it. And I wanted to come up with what the formula was for this. Well, I could go through each carbon and figure out how many hydrogens it has, but that'd be a horrible process. What I could do instead is say, hey, this has 1, 2, 3, 4, 5, 6, 7, 8, 9 different carbons, right? So C9. And then after that, I can count that I have a double bond, lose 2, double bond, lose another 2 for each. So I'm at 6 lost for hydrogens. And then I have a cyclo shape, so that's another minus 2. So I'm going to lose 8 hydrogens from the alkane kind of general formula. So C9, 2n plus 2, so that puts me at 20. So this is going to be C9H12, okay? And I'm done. I don't have to count all the hydrogens. I can instead look at the double bonds, the closed shapes, and kind of go from there. All right, well, going back to this, we also have hydrocarbon derivatives. The ones that you learned is organic halides, right? So where I have chlorine, iodine, bromine, and fluorine kind of mixed in with hydrocarbons. I have carboxylic acid, so I have my carboxyl group. I have esters, and then I have alcohols, of which you should be able to identify when it's a primary alcohol, a secondary, or a tertiary alcohol. And that all comes down to how many carbons are attached to the hydroxyl group carbon, right? So here I've got 3 carbons attached to that, so it's tertiary. If I have 2 carbons attached to that hydroxyl group carbon, it's secondary. If I have only 1, it's a primary. So that means that the hydroxyl is right at the end for a primary alcohol. Now, also wanted to kind of show you this. This is a summary of all the different types of reactions that you've learned so far. And I think you might not be able to see this whole thing. Let me see if I can move it 1 second. Okay, so if I take a look at the different types of reactions, combustion, if I have oxygen, I know it's combustion. For addition, I'm adding something to a hydrocarbon that's unsaturated. So as soon as I see a double bond or a triple bond and it's not an aromatic, it doesn't have benzene, then I know that I'm going to have an addition reaction, and I can add hydrogen, halogens, hydrogen halides, or water to make alcohols. So the big thing you're looking for an addition reaction is one of the reactants unsaturated. If the reactants are saturated or it's benzene, then instead it's going to be a substitution reaction. And for that, I'm substituting either with halogen or a hydrogen halide. And all that does is a hydrogen gets replaced with a halogen group instead. Elimination, okay, there I have either a hydroxyl group on there or an organic halide. And then I also have hydroxide as a reactant if it's an organic halide, and then I'm eliminating something. So I'm taking something away to make an unsaturated hydrocarbon. And then esterification that we've just done is really easy to identify. So what I'm trying to show you with this is that there are really big things that differentiate these different types of reactions in terms of the reactants they have. So for example, as soon as you see something saturated or a saturated or an aromatic, you know it's going to be a substitution reaction unless it has a hydroxyl on there or it already actually has a halogen and it's with hydroxide as a reactant as well. If you see that it is unsaturated, so it has a double or a triple bond, then you know it's going to be an addition reaction. So just kind of using those things as guides, you can really figure this kind of stuff out and realize what type of reaction it is. Try out that reaction practice worksheet. I think it's really good to go through that. And then also there's going to be a video solution for that. So that's good to go through as well in order to see what you've done right, what you've done wrong. And that should be a really big part of your learning for reactions, because reactions are by far the most difficult part of this whole unit, right? Memorizing the different types of reactions and predicting the products. It's not easy. It's a big thing. Also, if you go to organic chemistry for university or college, this is a lot of what you'll actually be doing is looking at reactions and stuff. It's one of the tougher courses in post-secondary, to be honest. Really interesting. I loved it. That's what I did most of in chemistry was organic, but it's tough. Okay, anyways, that's the summary. Hopefully that helps a little bit with some things. And yeah, enjoy the rest of your day.